Hello, Math Studies students, and welcome to your online lesson. Today we will learn to graph quadratic functions, and we will also identify characteristics of parabolas. We will know we are successful when we can efficiently interpret and graph quadratic functions. So a quadratic equation we've looked at numerous times throughout the last several lessons. The most important attribute, as always, is that it has an x squared with it. It may also have a bx and a c. A is the coefficient of x squared. B is the coefficient of x, or the number in front of it. And then c is a constant. And we usually like to get it in the form of ax squared plus bx plus c equals 0, though it can present itself in other forms. A quadratic function has inputs and outputs. That's what makes something a function. So we input some values of x's, and then we could find out what our output is, our value of y's. Or even better yet, we could use function notation where we plug in a value of x and again figure out what that value is. This isn't a lesson specifically about function notation, but both of those are acceptable ways to write quadratic functions. What this is a video about, though, is about graphing quadratic functions. So the graph of a quadratic is called a parabola. We actually saw a quick sketch of those when we were solving via our calculators on our last lesson, and we saw that the calculator would display that sort of cross or mash up between a U and a V, where it's got this overall U-ish shape, but it also has some attributes of a V where it's sort of expanding out. That would be an example of a parabola. They can either be positive, where they are facing upward, or they can be negative, where they are facing downward. And the vertex of a parabola is the point where the parabola switches direction. So for example, on the first parabola I drew, the graph was going down really steeply at first, and then still going down, but a little bit less steeply. And eventually it switched to start going up, so on and so forth. But right about here is where we had our vertex, that spot, that bottom, where it switched from left or going down to going up to the right. And so we call that the vertex. We've talked about vertexes in geometry as well, and that would be like the corner of an angle. And again, the vertex is where it sort of switches direction a little bit. It'll either be the lowest point if the parabola is facing upward, like where it holds water, or it's the highest point if it's a parabola that's facing downward, like my second example over there. Now, the x-coordinate of the vertex can be found using this equation right here. And this should look familiar because it's part of a bigger equation that we looked at 2 classes ago from the quadratic equation. And I'll write that here for you now. So our quadratic was x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, if I get rid of all this stuff here, also known as the discriminant, I end up with negative b over 2a, which is exactly what we have here to find the x value of our vertex. To find the y value, what we would do is take this and plug it back into the original function and figure out what y would be at that point. All right. So an important formula, it is in our IB formula packets, but again, if you know the quadratic formula, it's just everything that isn't affiliated with the square root. Also on a parabola, we know that they are symmetrical. Symmetrical means that they're essentially a mirror image of each other. And the mirror, or the line of symmetry, goes right through the vertex. It's a vertical line. And now this vertical line is not actually part of the parabola. The parabola is that sort of U or V-shaped thing. But there is this line that exists that is essentially a reflection, where everything to the left of this line of reflection, or this line of symmetry, is equidistant to everything to the right of it. And so if you know what half the parabola looks like, you can then reflect any of its points over and find out what the other half is going to be as well. Now this line, which again is not technically part of the parabola, but is a good attribute or a good characteristic or helps create one, that is called an axis of symmetry. And since it's a vertical line, most lines we often write in the form of y equals mx plus b. But a vertical line doesn't work in that fashion because its slope is going straight up and down. So we don't use y equals mx plus b, we use x equals form. And so the equation of the axis of symmetry will start with an x, And then going back to our quadratics, ax squared plus bx plus c, we plug in our b and our a value. And that should look familiar twice now because it's the exact same way we find the x value of our vertex. And it makes sense because this vertical line goes right through our vertex. And so it should have the exact same x value at all points. It's just that our vertex will also have a y value, whereas the axis of symmetry is just an equation, and you will need the x equals to make it truly a vertical line and to make it an equation. Let's look at a more detailed picture of all this. So here we've got a parabola. It's written as a function, so we can see that we have y equals ax squared plus bx plus c. And again, you can have zeros for any of the a's, the b's, or the c's. You can also have a 1 or any other number. I guess you technically shouldn't have a 0 for the a because it wouldn't be a quadratic anymore, but any of the other values could be. And then we have this dotted line, which represents our axis of symmetry, as is labeled right here. And x is equal to negative b over 2a is the equation of this axis of symmetry. And our vertex right here, it will have an x coordinate that is negative b over 2a. And once we know what that is, we can find the y by simply plugging this value into this equation for both of the x's, simplifying and figuring out what y is. But again, this is a better pictorial representation of a parabola with some of its key attributes, including the vertex and the axis of symmetry. All right, so we're going to start here with our first example, example 1, by sketching a graph of the following quadratic equation. Now, sketch is a command that you will often get from IB, which means we don't need it to be highly detailed. And for our purposes, we just want to talk about these attributes as we create it. So I'm going to start off with like an x and a y axes. And if I wanted to make it really nice and neat, of course, I would be using graph paper. But I'm just going to make a quick sketch here. I'm going to put a little scale down. I'm going to use a scale of 2 here to go along with my tallies. Notice I'm going every other one, which is totally fine for a sketch. I will put on a vertical scale as well. And we'll go in the negative direction here. This, of course, being my y-axis. All right. So a lot of students really spend a lot of time trying to construct their scale, and making a nice, beautiful graph is a great thing. But when the directions say sketch, they're looking for something that you can create in a minute or 2 or 3, not something that's going to take us 10 minutes to do. Now, to create any graph, I can always just find points by simply making a table here and plugging values in. So for example, if I want to figure out an x and a y value, I can pick any number in the whole wide world for x and then see what y I get out. So for example, a nice good one to plug in is 0. So now if I plug 0 in for each of these x's, what I'd end up with is y is equal to 0 squared minus 4 times 0 plus 1. 0 squared is 0, minus 4 times 0 is 0, plus 1 gives me a 1 out. So I know one of the points on my graph. It is 0, comma 1. So I move left and right 0 from the origin, and I go up 1 point right here. And that's going to be a point on my graph. And I can continue on doing this. I could plug in now a 1 for x and figure out what y is. So let me erase my previous work here. And now if I plug in a 1, y is going to be equal to 1 squared minus 4 times 1 plus 1. And so I end up with 1 minus 4, which is negative 3, plus 1, which gives me negative 2. All right, so that is another point on my graph. So 1 over, and then down 2 is going to be down here. Now, if this were a line, that would be good enough. I could just take out a straight edge and connect those together. But this is a quadratic or a parabola. Now, I could continue on randomly picking points, but I'm really interested in a key point that we have here known as the vertex. And I know how to find the vertex. It is equal to, or its x value at least, is equal to the opposite of b over 2 times a. So what is our b value? Well, our b value is right here. It's negative 4. So it's a negative 4, or as you heard me read it earlier, the opposite of negative 4, which is a positive 4. And then we have 2 times our a term. Well, our a is always the coefficient of x. It's the number x squared, I'm sorry. It's the number that's multiplying x squared. And we don't have anything in front of x squared, so there's an implied 1 of those. So that means that our x value is actually equal to 4 over 2, which is equal to 2. So we know that our vertex is going to have an x value of 2, but the question is, how do we find the y? We simply plug it in. So I'm going to use my function again to find my y value. It's equal to 2 squared minus 4 times 2 plus 1. And when I get 2 squared, that is going to be equal to 4 minus 4 times 2, which is 8, plus 1, which gives me a final y value of negative 3. So when x is 2, y is negative 3. And again, this was my vertex. Also, as we know, we had an equation that said that our axis of symmetry is a vertical line that uses the exact same setup as we used for our vertex. So first let me plug down my vertex. We said it was 2, negative 3. So I go over to the right 2 and down 3, and I can plot a little point right here. But I'm going to label that now as my vertex. That is going to be the lowest point on my parabola. And so I've got 3 points here. One is the vertex, 2 other random points that I got just by plugging in easy values for x. And now what I'm going to do is sketch my axis of symmetry, that vertical line that goes right through the vertex, which would be the equation x equals 2. And so right when x equals 2, which is right here, I'm just going to draw a vertical line. Now we dot it, not because we always dot lines, but just because this isn't actually part of our graph, but it's a useful reference for our graph. And so I just want to have it there as a reference, but not to grab too much attention. So we had this point right here, which was at 1, negative 2. And now all I'm going to do is reflect it across my axis of symmetry and put a point right there. Or maybe I'll do it in red to make that look a little bit better. And then we had this point right up here at 0, 1 that we started with. And I'm going to reflect that. It's 2 units away from the x-axis. I'm sorry, from the axis of symmetry. So I'll go 2 units over in the other direction, and we'll plot a point there. Now, you certainly don't need to draw all those green lines, but I just kind of want to show the process that I was going with there. And now I'm just going to try to neatly sort of complete this parabolic shape. Put arrowheads on it to indicate that it's continue vertically, continue rising, and also go to the left and the right. And that, ladies and gentlemen, is a parabola that I've graphed entirely by hand. I've sketched it. Could have done it a little bit faster, but I guess it took me about 3 or 4 minutes to get the whole thing done as I sort of walk through this process. Now, we could also graph these things on our calculator, as we saw last time, and we could spend a little more time looking at that. But I want to leave it here for now, just using our hand sketch as a way to, again, sketch, as the problem says, a graph of our quadratic function, or to sketch a parabola. Now, for our second and final example, I'm not asked to sketch the graph. I'm just asked to find the vertex and the axis of symmetry. And I don't have to go through the process of making a table or doing anything like that. But what I do want to do is get my my equation first all by itself. So I'm going to start off by having 2x squared plus 5x. And there was a 12 over on the right side, so I'm going to subtract that from both sides. Those will cancel out, and so I'd have minus 12 equal to 0. Well, if I want to sketch this graph, I'm essentially thinking of this as y is equal to 2x squared plus 5x minus 12. No equal sign needed. And so I could sketch this graph by using this, but I'm not going to sketch it. I'm just going to go straight to my vertex and my axis of symmetry. So for the axis of symmetry, I'm using the exact same equation as the vertex. I use x equals negative b all over 2a. Now I am going to plug in my b value, which we can see here is 5, but I want the opposite of that. So I'm going to have negative 5 all over 2 times my a, and my a term was 2. So I have an x value here now of negative 5 over 4, or negative 5/4, or negative 1 1/4, or negative 1.25, or any of those sorts of things. Now to find my y value, I need to plug that negative 5/4 into my original function, which I created right here, and get my output. So I know that y is equal to 2 times my negative 5/4 quantity squared, again, this being my x value that I plugged in for this x right here, plus 5 times that same value, negative 5/4, minus 12. Now, why am I not multiplying that? Because there was no x after the 12. That was just my constant. Now, I'm just going to plug all those values into a calculator, and I end up with a value of negative 15.125, or if I make that into a fraction, I can press math, enter on my TI-84 calculator, and it comes out as negative 128, I'm sorry, negative 121 over 8, or negative 121 eighths. So what is the coordinates of my vertex? I'm going to list it as an ordered pair because it's a point, and I will have negative 5/4 and then negative 121 all over 8. So 2 fraction answers there. Finally, my equation of my axis of symmetry, I just go back to the x value of my vertex. It does have to be an equation. The most important part of an equation is an equal sign. It should start off with x equals because it's a vertical line, and it should equal negative 5/4. And so that will be a vertical line that runs through the vertex, which is at negative 5/4, comma, negative 121 over 8. All right, we are out of time, and that concludes our 2 examples. Again, we looked at solving graphing quadratic equations using technology.